Every PCB interconnection can be construed as a transmission line. The signals that travel on the PCB traces or PCB interconnections are basically time varying electrical voltages or currents. And these signals, along with their return paths, form a closed loop circuit. It is important to remember that the signal travels on PCB traces with a finite speed, which causes a propagation delay. The speed is pretty high. It's roughly about half of the speed of the light, and we will give you the exact relation by which you can calculate that. But basically, this speed will give a propagation delay. If a trace is, going from left to right, then signals travel at a finite speed, and the propagation delay is expressed in terms of picoseconds or nanoseconds. Another important thing to remember is that the signals attenuate as they travel. Their amplitude reduces as they go further. Smaller traces, not much of attenuation, but as longer traces are there, the amplitude may reduce considerably. And another thing is that the signals will go some kind of a distortion because of the frequency response of the various, the attenuation may be varying with frequency. Other things may be varying with frequency, and signal is composed of a set of several frequency, and therefore the signals will undergo distortion in terms of pulse shape and other things as well. Excessive propagation delay, excessive attenuation, excessive distortion on a signal will affect circuit's desired functionality. A signal, if it has been reaching at the destination at a much later time than designed for, it would definitely not perform its function at the right time. If it is attenuated, its logic level may be interpreted wrongly, and if it is distorted very much, then basically the sampling of it will also give wrong information and erroneous information. In general, longer traces will degrade more than the shorter ones. In the PCB design, we need to ensure that signal interconnects must not cause more than a specified maximum propagation